Good day, my dear students. There is your headless teacher for today. We are going to look at the second example on the translated parabola. The question is asking us to find the vertex and the focus, and also find the equation of the directrix. Then we sketch the parabola. When we have done, we need to also find the length of the latus rectum. So let's begin. Before that, we need to compare this question to one of the basic formulas of the parabola. So in this question, you are going to choose y minus k squared equal to 4px minus h. So it's a translation parabola. So that is the orientation that is suitable to be compared to the question. We need to find our p by comparing 4p to this 4. And our p is going to be 1. With this, we are also going to get our 2p to be 2. Whenever we are sketching a parabola, we need our 2p for the extension of the other ends of the parabola. We also need our point, our vertex. So the vertex is taking the form h, k. And upon what we have here, our h is compared to positive 2. But when you're writing it here, you change the sign to be negative. And our h, k is also compared to negative 3. It becomes positive 3 at this side. We also need to find the directrix. So the directrix is the equation. So x, since it is found on the x-axis, so it's going to be x equal to h minus p, whereby our h is negative 3 and our p is 1. So we have x equal to negative 3. Then our focus. The focus is going to be, so then f for focus, h plus p comma k. So if you compare this, our h supposed to be negative 2 plus 1 comma 3. So we have it to be negative 1 and 3. We also need to find the length of the latus rectum. So the length of the latus rectum is equal to 4p. So we know our p is 1, so 4 times 1 is 4. So the length of the latus rectum is 4. Let's sketch our parabola. So we number the axis. All right, so we need to show our vectors on the parabola. Negative 2, 3 is found here. I need to draw our new plane at our new vertex. Supposed to be a dotted line. Then also the same for the y-x-axis. We have here to be y prime and x prime. We have the x and y coordinates already there. So we are supposed to find the p. So p is equal to 1. That tells you one skip forward from the vertex. This is our vertex, the point of the parabola is the vertex. So one skip forward will give you negative 1. That will be here. And that still give us the focus, negative 1, 3. We need to find our 2p. That's the two skips extension on both sides of the y-axis. So we have it here to be 5. We have here to be 1. So when we extend them to form a box, let's draw the parabola to pass through the ends of this box, and it should also pass through the vertex. All right, so this is our parabola. And also let's show the directrix, which is negative 3. And directrix is one skip away from our vertex. Because our P is one skip away from the vertex, the same applies to directrix, which is also supposed to be one skip away from the vertex. So we are going to draw the directrix as a straight line, and the equation for directrix is x equal to negative 3. So you need to write the equation that helped us to draw the parabola beside it, and that is the question given to us. Y minus 3 squared equal to 4x plus 2. Alright, so the length of the lattice rectum means that the distance from the focus, this is the focus, to the directrix, this is the directrix, is 4p. So initially, the distance from the focus to the vectors is 2p. The distance from the vectors to the directrix is also 2p. So from focus to directrix will give you the 4p, and that is the length of the lattice rectum found in the parabola. All right, thank you for watching. Let's meet in the other video.